Hello Mansa, how are you?
I'm doing good.
Yeah.
You're-
So can you quickly introduce yourself, Mansa?
Yes, sure. So my name is Mansa, and I have pursued my master's in computer science, specializing in
Mhm.
software technology. So during my master's program, I have worked on several projects, mostly related to collaborative environment development. That is basically like a Google Drive. We try to set up the similar application from our end as well. So that was my master's project, as well as a master thesis that was extension part of it. Well, after that, I was working as a Java developer in one of the private companies, wherein it was more towards developing seamless HR assistance, wherein they develop the certificates directly, like without having any manual interventions. So there, I tried to integrate the HTML5 PDF viewer into the application. So this was my work as a Java developer. And post that, I tried to explore on other domains because I wanted to broaden my area of, like my career. I wanted to take it to a next level. So I came across big data courses taken by you, and I did attend them, and it was like very knowledgeable, and it gave me a very good confidence on big data technologies. And post that, I started working as a big data developer, wherein it was mostly towards the banking domain. And yeah, so as a it
Okay.
was
So
a different
Mansa,
experience.
sorry to interrupt. How much total experience you have?
Well, altogether, I have 5 years of experience. In the big data world, I have three years of experience
Okay, that's
in
nice.
the
That's
banking.
nice. Okay. Can you tell me about some of the latest big data projects you have done, or what kind of work have you done in big data space?
Well, to start off with, my initially I was into analytical processing and all of this, wherein it was carried out on traditional databases, and that kind of hampered the real-time transactional activities because like all the processing was done on the database, and that impacted the transactional. It made it slower. So post that. I saw the difference, like as a big data developer, when I started working. It was more so towards how you can put that into an environment, distributed environment, and kind of decouple it from the transactional operations, so that this transactional operations can be done in a better way.
Okay, okay. So basically, you meant to say some of the reporting that you used to do on your DBs, you moved it to big data environments?
Yes, since because of the challenge that it was kind of laying back on the transactional activity. So this migration towards to big data was really helpful. That I would say.
Okay, okay. Fine. Now, what is one of the latest project you have done on big data?
Um, I have worked on this project wherein we kind of detect the fraudulent transactions from like whenever a person swipes his or her card, those transactions should be detected and marked as genuine or fraudulent based on certain rules. This kind of gives that off late everything is all the transactions are online, so it becomes more so important for all of the banking sectors to have this, so that they can avoid on the number of fraudulent transactions happening. So
Okay.
latest projects that I have worked on.
So what kind of technologies have you used from the big data tech stack in this project?
Yes. So initially, to be able to ingest the data into Hadoop environment, we used Sqoop, and to be able to also we used to get third-party data from, like, for example, we used to have three tables: credit card details, member card, and the credit card transactions. So this credit card transaction was the historical data, and the other two tables were like provided by the third party, because the card members keeps on changing the member details. They frequently change, and they are provided by the third party. So ingest that particular data from the cloud. We were provided on the AWS cloud. So we ingested the data into the Hadoop environment, and for ingesting the data, we used Sqoop. From there on, we created the Hive tables for better optimization and processing. And also that is where we used Hive. And also we had this need that the customer support can get this access to the data, so that they can quickly support the customers. That is where we used HBase for quick retrievals. And for the processing part, to be able to calculate certain rules, and based on that, which we can mark the particular card transaction as fraudulent or genuine, we used for the distributed processing. And well, so for the streaming part, to be able to given that get in the live streaming transactions, we used Kafka. Yeah, so these were the technologies that
So
that
basically,
came
you have
into.
used Sqoop, you have used your Kafka, you have used HBase. Did you use Hive and Spark?
Yes, yes, we did, because we needed this transactions. Basically, since it's a historical data, we cannot calculate those values on the fly because of the SLA we had to meet. So we had to take in just 10 transactions, so that those are kept up to date, and we can quickly retrieve the required data, and take out whatever the related records are required, and take those values and cross verify with the current transactions, so that that happens on the fly and in a very short duration of time, within few seconds.
Understood. Understood. So, understood. So, majorly you have used a lot of technology. So, on majorly which technologies were you working inside this? Because were you working on all of these or a part of it?
Well, I would say that I was mostly into ingesting the data, working on scoop jobs, and like automating the jobs and writing scripts, so that we don't have to manually rerun it. So we just write the scripts, and we can ingest the data into the Hadoop environment.
So, you were just working on the scoop part of it. That's it?
Towards scoop part, and also the hive tables as well, how we could optimize, how we could partition and bucket all of those, all of those concepts also I was into.
Okay, okay. So, in any of your project, have you worked on Spark as well?
uh, Yes, in this part as well, to be able to calculate the UCLs, there are three rules that had to be followed to be able to detect a
Mhm.
card as, card transaction as fraudulent or genuine. So these three, where there was certain formula based on which we can get that UCL value. Person
Understood.
transaction goes beyond that UCL value,
So
then
that's
it
fine,
has to be
whatever rules were those, but you did some of the
crossed.
Spark work in this,
Yes,
right?
exactly.
Okay, understood. Fine. So looks like you have done a lot of work on Scoop. So let's say if your Scoop job is not performing well, then what all problems might be there? I mean, how will you figure it out that what's the issue?
Okay, scoop jobs, as in one of the main, errors that I have encountered with scoop is that, suppose if we have a transaction that is like way beyond the particular limit of transactions that we have, data we have, then that is like an outlier, and that kind of impacts the parallelism of the computation part, because some of the mappers would work and the others would sit idle. In that case, this could kind of hamper the parallelism.
Can you give me an
So,
example around it? I didn't get it. Like how exactly it will happen?
for example, let's take an instance of an employee table, and it has certain records in it, maybe 10,000 records. Okay,
Huh?
and there is one entry, maybe by mistake or through some error. This entry is like an 1 lakh entry, so that one record has this ID of 1 lakh, right?
Mhm.
So that kind of acts as outlier, which is like which is which is just way beyond the particular limit. So in that scenario, whenever we divide the task among mappers, that is based on the unique ID, the maps get the job gets divided among mappers. In which case, one of the mappers have to perform most of the tasks because there are only 10,000 entries, and the remaining are they are no entries at all up till 1 lakh. So that
Correct.
1 lakh is acting as a hindrance. It is making the it is slowing down the parallelism and kind of
Okay,
the number of mappers working in parallel are
understood. So how
reduced.
do you solve this problem then?
To be able to remove these outliers, there is something called as a boundary val query that we had worked on. So the boundary val query is we kind of manually tell, or we hard code the values into the we tell the system that yeah, these are the values that you have to consider while dividing the tasks based on the column ID. And so we, for example, we just mentioned the lower limit as 1 and the upper limit as 10,000. So those are the only records, the actual and up, the
And
outlier
how
is not
about the
considered.
record 1 lakh? The one that was an outlier?
Sorry.
How about that outlier record? How do you ingest that?
So we can also, to be able to understand how the outliers are disturbing the environment, we can manually insert a record into the data set, and then we can check how those impacts. But
No, no, no.
in
My
real
question
world,
is not
in
that.
real
Mansa, my question is, let's say you tweak the boundary well query and you say minimum is 1, maximum is 10,000. But there was an extra record 1 lakh. How are you going to ingest that? Because when you say min 1 and max 10,000, that the record with the value of 1 lakh won't be inserted, right?
yes, right.
Yeah. So
So
how will
only
you be
these values will be
ingesting?
considered. The main criteria of like boundary val query is to remove the outlier from the picture. So that is where we don't ingest the outliers.
But if you have to ingest the outlier also, how will you be doing that?
um,
So if we say minimum
uh,
10,000 or minimum 1 lakh and maximum 1 lakh, will that work? That should probably, right? A second query probably,
yes, yeah, yeah,
right?
that should
Okay.
work, yeah.
Any other thing that you can think in Scoop which can improve the performance?
um, Coupa, as in like the properties that we can add to the scoop job, or
Might be your Scoop job is not performing well. What could be the other reason? Boundary well and all outlier, I understood. Any other thing you can think of? Anything based on
um,
primary key or something?
uh, yeah, there is one more scenario where the basically we should always run a scoop job, or the division of the work should be done on a numeric value. If in case if you are running a
Okay.
primary base, if it is non-numeric value, suppose a string, then it would kind of lead to some like drawbacks while we are ingesting the data. So we should always consider having a numeric column for the division of work, division of labor among the mappers.
Okay, okay. Let's say if there is a table on which there is no primary key and I am trying to do a scoop import, will that work?
No, it wouldn't work. In such scenarios where the primary key is not present, then we could use split by value parameter to be able to tell the particular system that you have to perform the division of labor on this particular column.
And that
So
split
in
by should necessarily be a primary key or not? There.
uh, yes, the split by should also be a primary key.
No, no. That's the question was right. If there is no primary key, then split by, right?
Yeah, then split by, but the value on which the column on which you are performing that, split by, is should also be a numeric value.
Numeric value. But should it be indexed or something?
Uh, yeah,
Is there any advantage
Yes.
if it is indexed?
Yes, in that case, only a portion of the data will be consideration. Like when
Okay.
indexing.
No worries, no worries. Yeah. Fine. In Hive, I think you have done some work. As you said, you created some tables and all. So what all optimization techniques you have worked on Hive?
So in Hive, I have come across there are several optimization techniques. So based on table structure level, optimization can be done at the table structure level, query level, and also the windowing function basically to improve. It kind of acts as a syntactic sugar. So in the table structure level, when you consider optimization, when you're creating the table itself, there are
Mhm.
two like partitioning and bucketing. So at query level, we would look into something that is more difficult. For example, these join operations are costly, and also they that has to be looked into when we are performing query level optimizations. So there we have map side joins and bucket map joins and sort merge points. And to coming into the windowing functions, they are more so towards I would say it's just to reduce the number of lines of code that we write. We can the complex queries into make it as a simpler query. So acting is just like
Okay.
I mean,
So can you tell me a slight difference in one line, probably the difference between partitioning and bucketing? When to use partitioning and when to use bucketing?
well, partitioning is used when there are when the cardinality of the column on which you are dividing is low. That is, there are unique IDs, and also the
Okay.
number of unique values are less.
Okay.
Bucketing comes when the cardinality is very high. So in those scenarios, you cannot have millions of unique IDs and divide the so that will be like a overhead rather than being a optimization. So in such scenarios, we use bucketing where we mention the buckets that are required upfront to the system, and based on that, it will be categorized.
So can you give me a example, like in what scenario, probably let's say this is the table and then we can do partitioning on this column and we can do bucketing on this column.
To example for partitioning, I would say, so for example, if we have to partition based on country, for example, so suppose we have an order table, and we want to kind of retrieve all of the orders that were made by the customers belonging to a particular state. In
Mhm.
that go in for partitioning because we can divide the data or partition it based on the state ID, and if that is the normal frequent query that we are running, that get me these set of data where the orders were being made in this particular state. So in that cases we can go for partitioning, and in cases for bucketing, I would say if you would want to, for example, if your query is more so towards if this particular customer ID, what is, how would I put it across? It's like based on this customer ID, you have to retrieve some data. So if that is a frequent query, then we can go in for bucketing. That is, we are searching on the customer ID,
Okay,
which is there are.
understood. Understood. So how many partitions will be there and how many buckets will be there? How do you determine those?
Um, Number of partitions are based on the unique or the values which we will be having. So it is not determined or it is not fixed by the user, but the number of buckets can be provided to the system upfront when the bucketing happens. Yeah.
Okay, upfront in the sense, so how many buckets should we create then? How do you decide?
That would be more so based, and also it will be trial and error, which would be the most optimal number of buckets that we can choose in. So there is no particular rule or a law that would, as law as in, there's no particular formula wherein we can calculate the number of buckets, but it's more so towards trial and error, I would say.
Okay. So can you have a hierarchy of partitions, like a partition inside another partition, things like that?
Yes, definitely. We can have an hierarchy because partitions are nothing but folders eventually. So we
Okay.
can have folders. Partitioning based on different, for example, partition based on the countries, then partition based on states within that countries. So this would be possible.
Understood. How about bucketing? Can we have hierarchy of buckets as well?
Bucketing wouldn't be possible because buckets are eventually converted as files. They are not stored as folders. So partitioning, hierarchy of bucketing is not possible. Or what we could have is like partitioning coupled with bucketing that would be possible, I would say.
Okay. Understood. Understood. Now, you said you have done some amount of work on Apache Spark as well. So, what is
Yeah.
Spark according to you, and why Spark? I mean, when we have all the things in Hadoop probably working fine, then what is the role of Spark?
So Spark, I would say, say it in simple words, it's a in-memory compute engine, general purpose compute engine. So it is a plug-and-play system wherein you can fit in any kind of storage device and the resource manager, and it's good to go. So MapReduce is, I would say, Spark is kind of a replacement for MapReduce because it can work with several languages, and it is not, as I said, it's a general purpose one, and also it has many in-memory features of wherein the data is taken into, whichever is stored in the local disk, it will be in memory, and there will be less number of IO seeks. So there is an optimization in case of fetching the data. So that is where Spark would give an advantage over, I would feel.
Okay, so it does not read from the disks. That's what you say?
Yes. So
Okay.
there, since the basic unit of Spark is RDD, these are the distributed collections of data wherein we store them in memory, and just for the reason that we don't have to get to the disk
Okay,
each and every.
let's say there are 30 transformations in Spark, right? Then does that mean we read from from like how many times do we read or touch the disk in that case?
We would be getting the data set once from the disk initially, and then we
Mhm.
would work the whatever transformations that has to be done on that particular fetch what we have made.
Okay, so you are saying only two times, just one for reading and once for writing. That's what you are saying?
Yes.
Now what about, I mean, if we say, let's say reduce by key, right?
Mm.
Will it not eventually lead for a disk IO?
Um, yeah, in such scenarios, we would have to get to
So
the
what
disk.
are those such scenarios? I mean, if you can elaborate. So when exactly a disk IO is required?
Whenever there is an action, in such scenarios, we would be wanting to.
Is it an action or is it a white transformation?
It's a white transformation. Yeah. In
Okay.
transformation, we would be requiring
What is a white transformation?
a white transformation is, for example, group by, reduce by, all of
That's
these.
fine, but what are such, I mean, why do we say white transformation? What's the property of it?
There will be a new stage created whenever a white transformation is applied.
And when is the new
So
stage created?
um, whenever there is a shuffle happening in that scenarios, um,
Okay, so basically, how many stages get created as per you?
based on the number of
Based on number of shuffles. Okay, and that eventually is number of white transformations, right? Yeah. So what are white transformations you are mentioning, Mansa?
Group by and reduce by all of these transformations.
How about filter?
Um, Filter is also an wide
Filter a
transformation.
wide transformation or narrow transformation? Is a shuffle required for filter?
No, shuffle is not required for
Then, I
filter.
mean, is it a wide or narrow?
Narrow transformation.
Okay. How about a map?
A map. Uh,
Map transformation.
Map is a narrow transformation.
Okay. Uh, how about reduce?
Reduce a wide transformation, I would say, because
But reduce is an action.
yeah, because it needs to collect all the data and then it needs to
Can you tell
reduce.
me the difference between reduce and reduce by key?
Um, Reduce. I
Okay, no worries, no worries. Fine. In Spark we have RDDs, data frame, data sets. So, do you know what is the difference among all of these?
Yes. So all of them are basically, like a collection of data, distributed collection of data, and
Uh-huh.
RDD are resilient distributed data set. It is an immutable one wherein we cannot change them,
Mhm.
and with respect to the data sets and data frames, uh, and also RDDs don't.
Your voice
So
is breaking. Can you repeat that? Your voice was breaking.
RDDs have no schema associated with them, whereas data sets and data frame have a schema associated.
Okay.
And also with respect to the optimization, RDDs are not optimized. It has to, I mean, the developers have to write a optimized code. Whereas in case of data sets and data frames, the optimizations, like we can use catalyst optimizers, wherein optimizations can be performed. And yeah,
So
so these are some.
how exactly is a data frame different than a data set? What's the difference between these two?
Um, I would say data frames are an extension to the data set. Also, in case of data frames, I mean, we can differentiate them based on the for example, the syntax errors and the semantic errors, the support that they give. That we can differentiate them based on that. So the data sets are, for instance, um, more for how say. So the data sets are. Let me just frame it for a second. Yeah.
Okay, no
Uh,
worries. Take your time.
um, so the data sets have the flexibility. I mean, like it gives both the advantage of the RDDs, complex lambda functions, and all of this. That strong typing of RDD is given, as well as the faster execution engine that's supported by Spark SQL. So these two are the combinations. I mean, like data sets provide the advantage of both of these. And with respect to the errors, both of data sets and data frames can catch compile time, I mean, like syntax errors at compile time, whereas data frames cannot catch this semantic errors. That those are analysis errors at compile time. Rather, data sets at compile time, both of them.
Okay.
But
Understood. Understood. Thank you. Let's say if you are getting an out of memory error in Spark, how do you debug it? How do you get to know what's the reason for it?
Well, out of memory error occurs when there is when like the amount of we can kind of
So first of all, have you ever encountered out of memory error in your day-to-day work, whatever projects you do?
uh, yeah, well, so most of the scenarios, because the Spark, it is only I mean, like it provides 1 GB of data for the analysis part of it. So if we have to keep on redoing it. That is a garbage collection part of it has to be done again and again. So this is where the out of memory error occurs, because we don't have the sufficient amount of memory. So in that case, we can increase the heap memory. That is so that is one situation. I mean, one solution that we could have.
But how will you track it out that it is out of memory error? How do you get to know?
We can use this Spark UI for that to be able to uh, debug the out of memory error.
Okay, okay. And let's say I'm reading a file which is, let's say, 10 GB, and my file is present on HDFS. How many partitions will be there for this particular, let's say, RDD?
Um, 10 GB, the size would be 128, and so 10 GB divided by
That
128.
is probably 80 partitions, right? Okay. Now, if I, let's say, do a transformation on it, let's say if I do a map transformation, how many partitions will I get?
Map would be 1 to 1. So
Okay.
uh, so 80 partitions.
Okay. Fine. And what if I do a group by key? Then how many partitions?
Um, the number of partitions will be sure on would be again based on the number of keys group.
Okay, no worries. Let's move forward. Now in your work, I mean, day-to-day work, what's the kind of volume of data, right, you have dealt with, right? How much data
Um,
do you deal with on day-to-day basis, I mean?
I would say somewhere around 3 to 4 GB of data.
3 to 4 GB per day. And don't you feel that if you're using big data systems for just 3 to 4 GB, it's like an overkill?
Um, well, we also will be dealing with the historical data that has
Mhm.
piled up over the years, and
Okay.
also we would be also looking forward to there will be an increase in the amount of data that we will be handling in the future as well. So, for the scalability purposes, we can definitely go in
Makes
for
sense. Yeah, understood.
system.
So Mansa, what is the most challenging thing you have faced in your project? I mean, because you have worked on multiple big data projects, some on the reporting part, some on the banking side. So, I mean, what's the most challenging thing that you have faced?
Well, as I mentioned, like there were several integrations that had to be done, like from one technology to that integrations were a little, so I would say a little bit challenging. Apart
Mhm.
from that, also these, I mean, like this out of memory error that we discussed. That was also a little bit challenging as well, I would say. Think of a
Okay,
few.
understood. Now, what's the size of cluster that you people use in your company?
Um, right now it's a 50 node cluster.
Mm-hmm. 50 node.
Yeah,
Okay. So any plans to grow that or something?
definitely thinking of in the future, probably an
And is
increase in
it
that.
on premise or on the cloud?
It is on premise right now, and we are thinking of migrating to cloud soon.
Okay. So are you aware of any of the cloud related aspect to big data?
Yes, I am aware of different concepts like glue, EMR, Athena, Redshift. So
Okay.
yeah,
What is EMR?
uh, um, it's
Yeah.
elastic map reduce, wherein it's a compute engine wherein it is like processing on a distributed manner on the cloud.
Mm-hmm. Okay. And what is glue, let's say?
Glue is, I would say, it is an equivalent to an ETL process, system wherein we ingest, take the data, and we use a concept wherein we infer the data on the data set, and we would be creating tables based on the data that is being inferred in the whatever database we would have configured, for example, Redshift.
So how do you infer the data in glue?
We create these crawlers.
Okay.
We add, and the crawlers will be able to infer the data from the schema of the data sets, whichever data set may be, whether it is semi-structured, unstructured data. So it tries to infer the data from it and then create a table with the associated schema.
So where is this metadata cap for this table, whatever we have defined?
The metadata will be, I mean, like whatever the crawler creates, the infers the metadata, we would be creating that in Redshift. I mean, that would be stored in Redshift.
No. Metadata, the schema part of it, is it kept in Redshift? Redshift, I believe, is to keep the data, right?
Yeah, yeah.
I believe there is something called as glue catalog, which.
Where we keep the metadata.
Okay. Now, what's the configuration of each node that you use in your cluster? And
Uh,
what distribution are you using? On-premise, you said, but is it the OpenStack you are using, or you are using with any of the vendors?
we are right now with Hortonworks.
Okay.
Uh, the cluster configuration is like it's a 32 CPU cores and 128 GB RAM and a few terabytes of hard disk.
Okay, understood. Fine, Mansa, I think we are good. We are probably done with it. And it was nice talking to you. And some of the questions you answered really beautifully. That's great. But Spark is something where probably a little bit of more, I mean, might be you are not in touch, but that's where I feel little bit you are lacking. Otherwise,
Yes,
all good.
yes, definitely
Any
we
questions
should.
you have, Mansa?
No, Sumit, I'm good. Yeah, thanks a lot.
Yeah.
It was nice.
Thank you. Thank you, Mansa.